Just a quick reminder on longitudinal versus transverse waves. Many of you seem to understand this, but then when it comes to questions, you get them confused or something like that. So I'm not sure what's going on. But the idea is that, so longitudinal waves, this is all about the vibration of the particles, right? So longitudinal waves are where the vibrations of the particle are in the same direction as the wave movement. So the particles, as the wave movement, and the reason, and so as the wave movement. So the idea is if this is your direction of the wave, this is your wave movement, then the particles, what happens in a longitudinal wave, particles, they are they're expanding and compressing. So you're going to get them, maybe they're really close together here, and then they get further apart, even further apart, and then they start to get compressed again. All right, so this is the particle movement, and this is the wave movement. They're all in the same, they're on the same, in the same direction, or it's parallel, you could say. Okay, now transverse waves. Oh, and the big example of longitudinal waves is sound waves. Those are the most common ones that we talk about. All right, transverse waves are ones where the particle movement is perpendicular to the actual wave direction. So that's the abbreviation for perpendicular. I'll write it out just in case, but ran out of space. Perpendicular. Sorry. Okay, to the wave movement. And so how that looks on a drawing, because they often say you can draw a picture to help you with this, or to help describe it if they ask about it. And so it's the same idea, is you have your wave movement. Make sure you label this stuff, okay, guys? You have your wave movement, and then the idea is that the particles are vibrating up, and then they'll go down. You don't have to draw this many arrows, but, and so the idea is that they're going up and down, right? Whereas as opposed to the particles moving, expanding and contracting. So these are instead going, you know, like you think of a wave. So transverse waves, for example, would be water waves are transverse. Any waves from the EM spectrum, so light waves, X-rays, gamma rays, radio waves, all those are all transverse.